Unit 2, Part 2. This looks terrifying. What do we got here? It looks like a perpendicular bisector, and then we've got some segments that connect to a point on the perpendicular bisector. Wait a minute. I remember these are congruent segments. If they connect to a point on a perpendicular bisector, I can set them equal. 2x plus 11 equals 8x minus 1. Then I'm going to add 1 and get 12 and subtract 2x and get 6x. And x is 2 because that point lies on the perpendicular bisector. Cool. How about 5? What do we got here? Angle bisector? Ah, yes. A point on an angle bisector is equidistant from the sides of the angle it bisects. That sounds so fancy. Let's just set these equals. 6x equals 3x plus 9. You're going to subtract 3x. 3x is 9, and then you're going to divide by 3. X is 3. We're awesome. What do we got here? So basically going the other way here. They're telling you that these are congruent, which means we might call this the converse. These must be an angle bisector. This GJ must be an angle bisector, so these angles are congruent. 5x minus 4 equals 4x plus 3. I'd subtract 4x and get 1x. Add 4 and get 7. That's it for my bisectors. How about this guy? We've got a centroid. Centroid, that means that these are all midpoints, and we call these medians. RK is a median, JT is a median, and SL or LS is a median, which means that's the midpoint. Those guys are going to be congruent, and these guys are going to be congruent. I'm not sure I'm going to need that, but while we're talking, let's do it. LS, which one's LS? This guy is 36. The whole thing is 36. Well, wait a second. I remember something about this. PL is half of PS, which means there's 3 parts here. If there's 3 parts, each one will be worth 36 over 12 is, or 36 over 3 is 12. This one will be 12. This one will be 24. Those add up to 36, and 12 is half of 24, so what do we want? PL is 12, PL is 12, and PS is 24. Cool. Let's see, I got too much stuff on here. Let's go next one. TP, what do we got here? TP is 20. Well, that means that this guy's going to be half of that. TJ is going to be 30, 20 plus 10, and PJ is going to be 10. All right, cool. What else? JR is 25. This is 25. Well, like I said before, this is the midpoint. So if that's 25, then JS is going to be 25. And RS would be the total. 25 plus 25 is going to give you 50. So remember, this segment, the short segment of the median, is 1/3 of the entire median, and it is half of the long portion of the median. Cool little trick there. Let's see. Wait, right triangle Pythagorean theorem? Okay, 16 squared plus 12 squared. This is a Pythagorean triple, actually. I know that it's going to be 20. You guys can do the Pythagorean theorem, I know that. 6 squared plus 10 squared. These are both the hypotenuse being squared, so these are the easy ones. That's x squared would be 136. I'm going to take the square root of both sides. The square root of 136 is about 11.66. So that's Pythagorean theorem. Now here we're going to use an extension of the Pythagorean theorem, and we're going to take the 2 shortest sides, 2 squared plus 4 squared, and compare them to what could be, maybe, the hypotenuse. Let's just say it's the longest side. 2 squared plus 4 squared, 16 plus 4 is going to be, 16 plus 4 is going to be 20, and 5 squared is 25. So here, since the hypotenuse is too long, these should be equal for it to be a right triangle. The hypotenuse is too long, we call that an obtuse triangle. If c squared is bigger than a squared plus b squared, we call that an obtuse triangle. If it's less than, it's acute, and if it's equal, we know it's a right triangle. Unit 2, Part 2, we're done.